All right. Hello, everyone. I am Adepi Bionke. I'll be taking you through the MEP design course, and for the short duration of this of the bootcamp, I was expecting to see the students and to have more people because I really hate talking to myself, but I've waited for so long. It's about almost 30 minutes past the scheduled time. I hope I'm able to get the recording straight and you can watch the recording later. And I think only God's power responded to me on the Discord group. But for now, we have to carry on and do what we have to do. I would really like to get to know the people interested in MEP, just to know what your background is. Are you a mechanical engineer, an electrical engineer? What are you currently studying? Are you a computer engineer? A software designer? Just know what your plan is for in the design space because MEP is very wide. It's a very broad, should I say, criteria. It's a very broad field, and a lot of um, a lot of things are involved. A lot of professionals are involved. So I would like to get to know each and every one of you. Even if it's on the Discord group, just tell me your name or send your email address so I get to know you. And this course should be tailored to meet your needs. So I need to know you and know where you are currently, if you are using any of the software, so that I can tailor it to meet your specific needs. And if it's that everyone is new and you've never tried any software, I will just start from that perspective. So I don't take people behind and I'm not too forward with my teaching approach. So moving on, I think someone just joined. Asemota Saritin. Can you hear me? Hello? Osaritin, can you hear me?
Yes, yes.
Okay. Thanks for joining. I'm happy now that I'm not alone.
Yes, I can hear you.
Okay, okay. It's nice meeting you. Can I meet you, Osaritin? Just tell me your name, if you are in school, and what you're studying if you are in school, and if you have any experience with MEP, just let me know. Osaritin, can you hear me? I'm not sure you can hear me, but if you can't hear me, it's still fine. I will still carry on. I just wanted to get to know you just before I continue. All right, the outline for today is to introduce everyone into MEP and run you through not just MEP as a whole, the industry, the construction industry, but from my perspective. I'm not an architect and I'm not a structural engineer, so my perspective is different. So the first thing I plan is to introduce you to the AEC industry, which stands for Architecture, Engineering and Construction. We are going to discuss that, and also we're going to talk about the basis of MEP design. What are the basic things to look at? What does it actually entail? Is it just drawing lines and pipe? So I would explain that, and also the global trends in the construction industry and also components of MEP design. What are the systems involved and everything? If I put the timetable of this course so that you can look at what I planned to teach. Even if you don't come to class, you have an idea of what we are going to be discussing. This is already in the timetable. Okay. I'll try to make my presentation very brief because I'm not a fan of long classes and discussions, I find out that long discussions tend to get boring and people miss out the main goal and the main plan of the meeting. So I'll carry on. For MEP design, what has changed for MEP design? Why is MEP all of a sudden coming forward? So in the construction industry, I think till around the 2000s, we the MEP guys were kind of sidelined. We didn't have true MEP professionals. There were very few people designing for MEP for homes. We had MEP designers, but they were working for government. They were working for municipalities, helping them do community drainage systems, but not really for homes. So at that time, in the 90s and 80s, and way before that, what we had was that we had architects doing the job of MEP engineers. They had to design, they had to draw the pipes too, and although the software they were using is not as sophisticated as what we have now, but even the structural guys, they had to do MEP work too, because it was not really a team at that time. So, but what has changed now? Things have gotten a bit complicated because of the advancement of technology and the need to provide comfort for homes. And as I would like to describe MEP, I like to describe MEP as the life of the building. I feel the architects, apologies to the architects and structural engineers, but I know they are not in this group, so I can say it. They work on the shell of the building. They work on I just call it shell. Anytime they give me drawings, I say, just give me the architectural shell. It's because I feel the building is lifeless without MEP, and it's true. MEP is the life of the buildings. It's what gives the building the art of the building, makes it functional, makes it adaptable makes it comfortable for human being. If it were in the past where we used to live in huts, yes, maybe no one would care, but now you want lights in your house, you want the air conditioning to work, you want to use the elevator, you want water to run in your house, you don't want to go downstairs to fetch water from a well or go to the stream. So all those things have made MEP more complicated. And the more complicated the building is, the more systems would require the MEP. So now why I'm talking about this at this slide is because right now the total cost of completing a building project, MEP is taking up to 60% nowadays. And why is that? Apart from the cost of MEP equipment, which is expensive, HVAC is expensive, fire systems, they are expensive. This is not just to brag about cost, but it's just to put relevance and importance to making buildings as comfortable as possible. When you have tall buildings, especially tall buildings, skyscrapers, where you can't rely on the outside for comfort, you have to kind of create a comfortable environment on the inside of the building. You tend to spend more money on MEP. So when the people operating the building start noticing that we are spending so much on MEP, why don't we spend time designing it to make it more sustainable? Why don't we spend more time designing it so that we can actually spend less than what we're supposed to spend? So that is where the idea came from, and that is why right now it is a very competitive field, a competitive industry. There are jobs, there are a lot of opportunities. With MEP, you can do and undo. That's the word for it. You can do anything you want to be. You can find yourself in MEP based on what you like. Do you like designing? Do you like project management? Do you like construction management? Do you like software development? Do you like data management? There's a lot involved. Do you like cost estimation? So based on what you find interesting, you can always find yourself in it. And for this course, Mimisola mentioned something to me. The coordinator of this course is that she wants at the end of this course for everyone that is a part of this course to be able to make a small project so that it can be like part of a portfolio, and I'm going to try to work and make that possible. But it also depends on the participants because I need feedback. I need to know where you are. I need to know if you have any of the softwares, if you've used AutoCAD before, or if you've used Revit, or if you've used ArchiCAD or any other similar software, just to know where you are at. Because for some people, this might be too basic. For some, it's not basic, it's exactly what they need. So I really need to find that out. And that's why I'm trying to talk to you, Osari. Once you can get your mic figured out, you can just give me some feedback on where you are and where your knowledge and skill level is on MEP. I would like to know that. So moving on, in the traditional MEP design process, way before now we have building information modeling. We draw with pencils and papers and detectors. If you're in school, I'm sure you did this or you still did, because I know Nigerians, our school system will not change. You still draw with paper. Drawing with paper is good. I would say it's good to some extent. It's good for the basic because it helps you get the feel of what you're doing before moving into the software. So it's good because it helps you get some basic skills about annotation, making your lines the right way, and things like that. But after a point, I think it should stop. But for now, in the past, that was the only thing. Even for the biggest buildings, you draw on paper with pencils. And when you come to site, you see the civil engineer arguing with the architects. They keep on arguing about this and that, scribbling on paper. But things have changed now. Things have changed. We have moved on to a better management system. And towards the end of this course, I'll discuss more about BIM and how you can get involved. Now, I said know your building. The reason why this is very important is that I'm an MEP engineer. I have a mechanical background, and some of you here might have an electrical background or some other fields in engineering. Or even for you don't have to even be an engineer to come into MEP per se. So, but the reason why I specifically said it is as mechanical engineers or electrical engineers or computer engineers, we are not exposed to building plans in school, and for most of us, I'm sure the first time you might see a building plan might be when you get out of school or when you're trying to get a job, or maybe you see one of your friends that is an architect doing an assignment or something. You can say, let me see what you're doing. That might be your first time seeing building. And for MEP engineers and anyone involved in the AEC industry, it is very important for you to get to know your building, know what the building plan looks like. Like know, like when you say building, when you say drawing, you're able to say, okay, this is a wall. On this wall, there's a window. Okay, you should be able to read sections. That is why I said your knowledge of engineering drawing is going to help, because of course in engineering drawing we're not drawing buildings, we're drawing machine parts and stuff like that, but it's still very very relevant because we use sections to kind of get the whole geometry of whatever we are drawing. Same is the same for buildings, but so when you see sections you can interpret it. You know what a door is represented as, you know what a window is represented as. So this knowledge is basic fine, we are not the ones designing, we are not the one drawing the wall, we are not the one drawing putting windows and all that, but we are the ones working on the building. It would be wrong for us to place a pipe where we are not supposed to place a pipe. It would be wrong for us to run our electrical wires, to run it through a column or something, but not to be able to understand this is actually a beam, this is a column, we shouldn't cross here. So it is very important to get to know your building, get to know how to read a building plan. The reason why I said it is the first project you'll be handling for this course is going to be very basic. You won't have to have the complexity of having a structural engineer as part of this. This will just be a simple architectural shell, as I call it, which I will share later so that you can begin to work on it. So that, for example, look at this on the slide, how you can see it. This is a simple building plan, very basic. It's just a single floor. I don't know how many of you know how a door is represented and what this means. Osaritin, can I get feedback from you? Hello, Osaritin. No feedback. I have to carry on. Okay. So for the doors, as I speak, the direction matters. The direction in which the door is going to open matters. The type of doors, it can be shown in the 2D plan, like this is a double door. It's different from a single door. The direction of the arc shows into which area the door will be opening into. This is a bedroom area. This are washing hand basins. This is a toilet. This is a kitchen. Like being able to identify basic things like that is really going to help you. Like you should have, as an MEP engineer, you should have an eye for drawing interpretation, both architectural drawing and structural drawing. For the structural, it might not come like easy, like you might not understand it immediately, but it's something you can understand in an hour or two by speaking to a structural engineer. If you are confused, for example, you are sent the structural drawing to so that you can superimpose and make sure there are no clashes in your drawing. One of the things you have to find out if you are confused about anything, you confirm from the structural engineer. That's what I'm saying. You have to be able to interpret these drawings, interpret the architectural drawings, interpret the structural drawings. So now, MEP systems must satisfy multiple objectives based on the criteria for design. I always say that because for MEP design, there is always a goal, like what are you trying to achieve? If you are installing an HVAC system, what are you trying to achieve? What level of thermal comfort are you looking at? What is the cost? What kind of system will be best suited for this building? Because of course, based on what you are taught in school, you know that for an HVAC system, we have different types. We can have single units, we can have multiple units having a multi-split system. You can have a centralized system. You can have arcs and you can use the cooling tower. You can use different methods and different systems. But all this is not to complicate the work of an engineer. It's just for an MEP engineer to clearly define the design objectives and the criteria considered. So we have different types of specialties and contractors with their specialties, but for now, that is not that is not important at this stage because I'm not going to be discussing contractors and their work and responsibility now because we are in the early stage of this discussion. But when I get to know the people in the class and know our level and our level of experience, then I can tailor our discussion into something more relevant to you. And for our assignment for this week, I would like everyone to like get their hands on an architectural plan. If you don't have one, just let me know. If you don't have one, just say on the Discord group that, excuse me, I don't have an architectural plan. Can you send me one or something? I will send one to you. You can send me your email address. I will send one to you. So what does MEP actually mean? Just a basic definition, but it's just a short form for everything. Mechanical, M, electrical, E, then plumbing, E. You wonder why they separated mechanical and plumbing. Yes, they should separate it so it doesn't get too complicated. For mechanical, we have the major part everyone talks about is HVAC, because HVAC is big, that's why. But under mechanical, we don't just have HVAC, that is everything. HVAC, I've forgotten the R part, which is refrigeration. Now, sometimes we forget the R part, but the refrigeration part is also very important. Because recently I got to work on a very big warehouse where within the warehouse we had refrigerating systems, large refrigerating units, the biggest ones I've ever seen in my life. So I had to pay special attention to the refrigeration aspect. Really, really detailed, as in really detailed attention, and I've never done that in my life. All I cared about before was just the HVAC area, the thermal comfort of the people in there. But when I was working on the R, I was working at zero, sub-zero, -0 degrees Celsius. So that is a different experience. Just to tell you how complicated MEP can be sometimes. So for the mechanical aspect, I've told you HVAC is a big part of that, but not just HVAC. For the mechanical aspect, we also have every other thing that makes the house or the home or the building. It can be an office space, it could be anything, more comfortable for people there. It could be elevators, escalators, travelators, mechanical systems of all sorts. Those belong to the M family. Now for the plumbing family, anything plumbing, anytime you see pipe, it's plumbing. And we know for plumbing we have all kinds of systems. Water supply, popular. Drainage, it's popular. Fire is popular. But we have other needs. Pipes are used for, if I know langas, you know pipes are used for different things. They are used for all kinds, but for now, everything they are all in the plumbing family. For electrical, we have two major parts, which is electrical, then the electronics in the building, then power systems and stuff. I'm not an electrical engineer, so I have little experience with electrical systems, but I work with them. I work with them because most of the time I don't design electrical systems, I design in the mechanical and plumbing areas, but I still work on electrical when I have to. So I would explain that to you, and yeah, that is like the basic definition. That is the main aspect. There are a lot. There are a lot which I'm going to explain as we move under MEP. But that's the basic definition of the systems we have. So the importance of planning in MEP. Sorry, let me go back. I think this slide should come first. Yeah. Let me just talk about this before going back to that slide. So for the AEC industry, I told you, to make a building what it is, it's not just us, it's not just architects. We have architects, engineers, contractors, quantity surveyors. I'm sure some of you in your schools, you have people studying quantity surveying. I'm not even talking about the surveyors. Those ones are different from the quantity surveyors, but they are all part of the AEC industry. Anybody that is doing something that has to do with construction, say AEC industry, both building and infrastructure, that is road, rail lines, anything, anything, telecommunication mast. It's all in the AEC industry. So now you wonder, how do all these people come together? Because the AEC industry can get complicated because we have, I think it's one of the industries where we have a real term called multidisciplinary. It's really multidisciplinary. We work with people with very different background, very different background. So when you work with people with very different background, it's like you working with people with different ideologies, but we are here to achieve the same goal. That's what it is. It could get messy. That's why we always have a project manager in the team because they get to manage the complications in the team and all that. So looking at it on the client side, the client can have client representatives. We have the facility management too on the client side because at the end of the day, when the project is done, we are going to deliver it to the client, aka they are the clients rep, the facility management team, and these are the people that will manage the building for the whole life cycle of the building. So this is what the lease industry kind of looks like. You have the architects doing their design and construction, you have the engineers doing all their jobs, the civil and structural. I'm sure if you go to the civil, the civil or structural engineering course of this bootcamp, you'll hear a different story because for them, they make a distinction between civil and structural. But for me, I just group it together because for this course, it's not really our business about how they divide their work. Because there's more to it. Even for the quantity surveyors, there's so much. In some countries like Canada, they don't keep quantity surveyors and say quantity surveyors for the whole project. No, in Canada, they have MEP quantity surveyor. They call them MEP cost estimators. Those ones are different from general cost surveyors, and they call some people cost engineers. All those ones actually to me is just title. We know their function, we know what they do already. So that's, and we have our contractors. They're a big part of the AEC industry. They're a really, really big part of the AEC industry. And as an MEP person, you can work on either side of it. You can work for a contractor, you can work for a consultant. So you can be on the project management side of things. Just basically, if you are working at for a contractor, for example, you are going to be receiving designs from the consultant. But the designs you receive from your consultant, you are still going to work on it so that you can give your guys on site to install. But that is a different. I would like explain that structure when we move forward because that structure it's it varies per country and per regulation. Our system is kind of different in Nigeria, and where I am, their structure too is kind of different too in Portugal. So, what you should know? Well, what you should know is what are the new trends in the industry? Not just new trends, what are the highlights? What are the goals of design? There are so much. And these days we are talking about sustainability, making buildings with less carbon footprint. And when you look at that aspect, a major focus is shifted to MEP. Because the truth is, to reduce carbon emissions and make your building as sustainable as possible, MEP has to be a big part of it because MEP is still flexible. But the structural guys, they are also working on it. They are looking at moving into greener materials, more sustainable design, less concrete, less iron fibers, carbon. They are working on carbon fiber reinforced plastic, using of CFRP, using it for casting pipes and all that, using less volume of of concrete and everything, working on concrete mixtures, reducing the weight of buildings. They are really working on it. But for the MEP part, it's huge because it affects everything for us. It affects our equipment selection, design, what kind of design we want. Like we might want to say, oh, we want to use a cooling tower or something, but if the cooling tower is taking space, and your clients don't have space, or if your cooling tower is taking a lot of fittings, a lot of money, so no, 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 no. And how sustainable is your design? Things like that. Is it bringing enough comfort, efficiency? Is it maintainable? We'll move to the part of maintenance later because, of course, as MEP engineers, it is our part of the building that is actually being maintained. It's not like people don't maintain masonry units, that is the architecture and the structure of the building. They do. Sometimes you can have a crack in the wall. Sometimes you have to repaint. Even sometimes to work on some MEP, to even do some MEP work, you have to break walls sometimes. So it's not like you're not going to have to touch them, but they are not like the main focus. The way you have to change light bulb, the way you have to change the burnt wire, you go to the electrical board, the fuse has burnt, things like that. Those ones are on a regular. So that's why MEP is so important and it's so relevant at the moment. But I would like to know how many of you have actually worked on projects. I would like to hear some experience and before I show you some samples, I have a lot of samples. I'm just careful with my samples so I don't give you some of my clients' jobs. Some clients are very strict because they don't want anything about their design or their project getting out to the public. So, all right. I'm just trying to see some of the services and any top MEP firm will provide. There are a lot, and you can choose to be a specialist in one or two or more, just based on what you like or what interests you. There's a lot to do. As I said, mechanical HVAC system, very popular. Central plant design, yeah. It's part of what I talked about in refrigeration. I had to design a CO2 plant and all that. Exhaust system, yes. These systems might not sound important to you if you are working on, for example, you are working on an home or someone is building an hotel or something. They might not an exhaust system isn't an exhaust system is even important in an hotel. It's very important because you don't want what the cook is cooking downstairs to be smelling in the room of one of your clients or your customers. No. So good exhaust system is very, very important. If you are building an apartment building, multi-story buildings where everyone will have their own kitchen, you don't want people disturbing each other. Of course, you have to plan with the exhaust system in an hospital. It's very important. You don't want disease spreading from third floor to first floor, things like that. So we always plan for the exhaust system, which is for taking air out of the building. Direct digital control system, chilled water system, that's under HVAC. Heating water system, it's still under HVAC. So we'll move on to electrical. As I said, I divided electrical into two broad parts. So we have under the electrical, I said we have electrical and electronics and we have power. Power is it's the reason why power is separated is because it is in power they get to mix with, like they get to work with other engineering field. For example, when I design, I send my equipment ratings, everything to the electrical engineer. Why? They use this for their power distribution system. They want to know the ratings of ACs. They want to know how many ACs I plan to put. They want to know everything. But if they're, for example, doing lightning design, they don't care. Like they don't need any information from me. So it's in power they get to mix with other engineering field because they want every information of the equipment you are putting, what is the voltage, rating, and everything. So for this electrical system, there's a lot. There's a lot. But these are just some examples. When I drop the slide, you can go through it. I don't want the meeting to run for too long. You can go through some of the systems and ask questions. For example, if you come upon one system, you can say, sound system, under which, who are the people working in the sound system of it? But that is still under electronics, not electrical. But CCTV, what is it? It is under which system? This and that, lightning, fire alarm. Fire alarm has mechanical aspects. It has electrical aspect. If you've heard someone, you will have heard of the FM 200, it's a popular electrical fire alarm system. So there's a lot on that, but I won't dwell on it now. Same with plumbing. I've explained plumbing before that and all that. The considerations we have for plumbing. I won't go into it now because I've made some examples earlier on. Now, modeling. For now, for this course, I don't think I'm going to take you guys to AutoCAD. Sorry, I like to drink water. The only reason I'm not taking you guys to AutoCAD is because AutoCAD is outdated. Sorry to say. It is. I still work on CAD drawings though, but I don't design on CAD drawings. The only reason why you see me working on CAD drawing is because my clients gave me CAD drawing. But right now, everyone is working to actively phase out CAD drawings. Like, it's not as if no one won't have CAD drawings. Don't get me wrong, because you will not carry 3D drawings to site. It's still CAD drawings you carry to site, but your design will be done in 3D enabled software, which will make it very easy, like with the click of a button, for you to get your 3D drawings. So that doesn't mean AutoCAD is useless. So please, AutoCAD is still useful. You still use it for a lot of things. I still go to AutoCAD sometimes. If you want to make some simple, fast annotation, you can still use AutoCAD. But for this course, we are going to be starting with Revit. And if you have any question, if you have any doubt, or you saw something, or you read something, or you tried something and it was difficult, or you didn't understand, or it sounds complicated, just go ahead and ask questions. And even right now, as I'm talking, you can ask questions. I don't mind interruptions. I really don't mind. I will still get back on track after answering your question. So this is an example of a drawing done in Revit. As you can see, it's a multiple story building. So what Revit allows us to do is it allows us to work on floors individually. This can be done in AutoCAD, but in AutoCAD it makes it more complicated. But an experienced AutoCAD user will do this. Would be able to do this fine. No stress at all. But in Revit it's very easy. Revit is to make things easy for you. It's easy, it's faster. You see, you have better visibility. You can always go into your sections easily. That is what Revit does for you. So this, I'm not going to be drawing, but this is what it looks like when you go to your plan views. These are plan views. These are plan views. These are just screenshots. These are plan views. On the plan views, you can connect your pipes, draw your pipes. You can see here, most times you have blue representing cold water pipes, red representing hot water pipes. So you can connect all your pipes right on the level in straight lines, and you can always go to the 3D view to look at it and say, is it well connected? Is it at the level? Do I want the hot water pipe slightly higher than the cold water pipe? Do I want it slightly lower? Those variations, they are very important. Before, we don't pay attention to it sincerely, because in the past when we draw everything on CAD, everything is in the same level. Even if there are clashes, most times we rely on the experience of the contractors we rely on the experience of the contractors to actually go to site and do things, even if they get to site and say, ah, how did this person do it? The hot water and the cold water, they are clashing now, there's no space. But at that point, we are going to rely on the experience of the contractors to make corrections and make sure everything is working as planned. So the way to get started is to, this is a quote, not by me, it's by Walt Disney. Yes, the way to get started is to quit talking and to begin doing. Yeah. So MEP, it can be complicated, but it can be very uncomplicated. That's why I say it's better to quit talking and start doing. Now, the way to uncomplicate it is to start from a software that is simple to use and also very, should I say, current. That is the word, very current. Something that is usable. It's usable for you. It is good for visualization because when you are new in the field, you need a lot of visualization to understand exactly what you're doing. And this is, for example, this is a toilet. This is what we are, these are the kind of flushing mechanism we have. This toilet tank and stuff, it will be recessed inside the wall. Actually, you won't see all this. You will actually not see all this. Now I'm saying MEP, our work is always hidden, but it's good because if your MEP work is not hidden, then it's ugly. It becomes ugly. It's not pleasing to the eyes. So this is how it's supposed to be. It's hidden, but within all this, for example, this is a waste pipe. It's going out of the toilet. This is the water tank. This is a drain on the floor. This is a shower discharge. This is just showing that all these pipes, they are connected and they'll flow out through a particular channel that we choose. The next class, I think in the next class, when I plan to talk about standards and some other things we use in MEP design. Because from MEP design, we don't just go ahead and draw pipes anyhow. No, we don't do that with design. We do calculations. We have the rule of thumb. Someone like me from little experience, not even that experience, but from little experience, I can estimate the water use in a building, but there are actually standards for these things where you can calculate what is the average amount of water they are going to be using in this house per day. Just the way electrical engineer can estimate what is the electrical consumption for a house with 4 rooms and 3 people, something like that. So there are rules guiding these things. We have in Nigeria, we follow certain standards, which I'm going to mention in the next class and talk about them a little. For some of you, I would post one thing that is very important and to make the class useful to you and helpful to you. I need a lot of feedback. I need to know where you are and what you're working on. And if anything I'm talking about sounds abstract, it's always good to bring me back and be like, no, I have heard of this, I've not heard of this. Or if it is something you've worked on before, you just let me know, oh, I worked on something similar, or I did this, but I didn't use this standard because there are a lot of standards. And I'm familiar with the one used in Nigeria because, of course, I worked in Nigeria. I use CIPSA standard and some other plumbing guide. That plumbing guide in my office is the Bible. It's the Bible for mechanical engineering department, the plumbing guide. As you grow older in the business, that's what my boss makes an example. My former boss, engineer Akirede, he always says this. He says, the older you grow, you start letting go of the book little by little. But once in a while, you still have to go back to the books. Those books are very important. They are very important because you cannot know it all. Trust me, you cannot know it all. So those books are important for you to do your calculations. It's important to do your calculations before moving into the software. That is if you are designing. If you are not designing, you are just drafting them. nothing concise. You just draw your pipe and go. TBI is 9, do your calculation on the outside. You have Excel sheets that can help you. We have tutorials online that can help you. We have a lot. So if you are confused, for example, you want to calculate this, you just send me a message on Discord. How do I calculate this? Oh, I heard this. How do I do this? And I put some link to some YouTube videos in this presentation so you can click on it and watch. They are very important, and they'll be very important because for you to do the assignment and the tasks that has been assigned to this course, you have to actually watch those videos. I can't come to class and start drawing pipes for people here. No, I can't do that. I can only do maybe corrections. I can do corrections, or if any one of you have a question, then I can do that. I can, if for example, say, I was trying to connect this pipe, it didn't work, or I tried this, it was not in the right system, then I can run that and go into that for you. So for what I showed here is just to show you that with a good software like Revit, ArchiCAD, I use Revit and ArchiCAD, but I don't really use ArchiCAD so much. But when you work with an architect that loves ArchiCAD, you just get used to it. But even if it's in the Revit or ArchiCAD environment, the you can get good detailed drawings, good drawings that can be rendered to make it look real. You can see everything you're supposed to see in levels because details are very important. In architecture, there's a part of architecture that just has to do with just detailing. And the reason why they spend so much time detailing is the visualization is a powerful tool, and the way the human brain works. When we see something appearing the way it's supposed to be, it's it gives us, I don't know, it gives us the push and the drive to carry on with the project. And it also it helps with the client. The client of course wants to see what is going to happen. They want to see, if you, even in Nigeria they do it. The architect will just show you one fine picture, but sometimes it's not real. But these pictures help because they help you to have an idea of what the finished product is going to be like. In huge projects and skyscrapers, in airport projects, groundbreaking project, visualization is a very important tool. Like in the Burj Khalifa, they have digital twins. That's just to show the emphasis laid on visualization. Moving on, I'd like to round up now. So, study resources. I put this there so that these two videos, one is a simple beginner's tutorial, which I would really like us to work on. Just click on it. The second one that I put, the simple beginner's tutorial, is by a guy called Balk, an architect. He's an architect, but he doesn't make model. So that just happened. The truth is, in the industry, once you're part of the industry, you can do everything. I'm an MEP engineer, but I can draw a building. I can model. I do architect's job sometimes. It's not that I don't do their job professionally, but if I have to, I do it. If I have an assignment, if I'm working on something personal, I'm going to do the architectural plans myself. But you don't really have to because there are professionals that are trained to do this the right way. But it's just trying to tell you that the longer you stay in the industry, the more you appreciate other aspects of the industry. You appreciate the work of the structural guys, you appreciate the work of the MEP guys, you appreciate the work of the electrical guys. Even if you know how to do this thing, but you just are specialized in one aspect of it. So please watch these videos by an architect, but it's very simple basics. Follow the steps it takes. It's going to guide you through something very simple, just a simple, I think it's a simple bungalow with one restroom. That's a toilet, the washing basin. It's just going to show you how to connect the pipes. So if you have questions on this tutorial, I would be here to answer them, and then we can discuss it in class. You can share your screen and tell me the problem you encounter, and then I can solve it with you. So moving on, I think this is the last slide. I think that is the last slide. Okay. Yeah, that was the last slide. Alright, but I'll share my screen a little bit to show an AutoCAD environment. I hope you guys can see this AutoCAD environment. So most of the time, this is what we receive as MEP engineers. This is what we receive from the architects we receive. Although this is not how it appears when we receive it. We receive drawings with a lot of pictures. You know, architects, they are designers, they are artistics. They like putting everything, colors, shades. And also maybe all those ones in our business. Because at the end of the day, we just want to draw our pipes, draw our dots, and be happy. Put them at the right level. So now this is a cleaned drawing. This is like what I receive. So I have to delete all this stuff. Delete some layers, lock some colors to get what I want so we can begin drawing our pipe on the right level, assigning layers. I won't go into this because I don't want us to work on the AutoCAD environment. We'll work on the Revit environment. I have closed the presentation, so I'll stop sharing. I closed this presentation, so I'll stop sharing. All right. So this is the end of today's presentation. The last slide, I think I just put my email address, which I'll put on Discord. I'll put my email address in case you want to send a message, but even if you don't want to send a message, you can always reach me on Discord. The slides will be available on, I don't know if I'm going to put it on Discord, but it's going to be available on Teams. Yes, it's available on Teams, but if you want it on Discord, just ask and you get it so that you can watch the YouTube video. I'll put the link of the YouTube video on Discord too. So thank you guys for coming to today's class. And I wish next class we have more people. It's really strange talking to myself, Ultra and Osaritin. Thanks for joining. I wish I could hear from you right before I end the class. Are you here, Osaritin?
Yes, I'm with you.
Why do you leave me? Why do you do me like this? You left only me to be talking. I was calling you, trying to get you to talk.
Yeah, the network was breaking at some
Okay.
points. Yeah.
Okay. But how are you?
Yeah. Very fine.
Okay.
Yeah.
Are you in school or you are done with school?
No, I'm still in school.
Okay.
Yes.
What are you studying?
Mechanical engineering.
Okay. Have you had experience with MEP? Hello?
But I didn't hear that.
I said, do you have experience with MEP?
I can.
Oh, I think the network. Sorry.
Not at all. I don't have any
Okay.
experience yet.
Okay. So please watch the YouTube video. That the YouTube video is also in the course guide. Just watch it. That YouTube video, what the guy was trying to do there is helps someone that has no idea, like zero idea. Just show you how to draw a simple plan, like how to draw a mechanical plan on an existing architectural plan. So it's important you watch that video.
Okay. It's on Revit, right?
Yes, it is on Revit. Do you have Revit? Okay. I was about to ask about softwares.
Yes, I got the Autodesk software, but I was not. I have a problem trying to install it, so that was just the issue now.
Wait, is it the student software?
Yes,
the student version.
The student software.
But the truth is, for AutoCAD right now, they've made it very easy to install their
Okay.
softwares, especially for student versions. You just use your email address to download it and click on one button. You wait till the end. It takes time to install, so you have to make sure your laptop is charging and you wait till the whole process till it's done. Because if you stop, even when it is 90 something, it is still not installed
Yes.
and it's going to affect your
Okay.
reinstallation.
Okay.
So you might have to delete. If it's that you've downloaded it and you tried installing it and it's installed halfway, you won't be able to use the software.
Okay. So I have to
Yes,
um
you have to
download
like
it again.
delete. Yes, and start and be patient. On the day you want to install it, just make sure your laptop is plugged because it might take time to install. And if you have any issues about installation, they are like um there are always new YouTube videos on how to install student version. Very short. Those YouTube videos they are not long. They are like 3 minutes YouTube video where they'll just show you how to troubleshoot. You hear me?
Okay.
All right.
Yes. Yes.
Okay. All right.
I can hear you.
All right. It's nice meeting you, Osaritin. I hope I can
All
meet
right.
more people. I don't think you're the only
Okay.
one in this course, but for
No.
now, you're
No.
the only one. All right. All right. Thanks
All
for
right.
coming. Yeah. Bye.
Thank you very much. Yeah. Bye.